Hello everyone, so welcome to this tutorial of viscosity. So before we get started, I need to take you this word which is called word of viscometry, and in this word of viscometry we'll be talking about this particular subject area of wide sciences which is called rheology. So basically rheology deals with all kind of fluid behaviors, and it also incorporates the deformation that a material go through. So before talking about viscosity, let's just imagine our whole world is made up of two things. One is liquid and other is solid. So there are few substances that comes in between them which are neither perfect liquid, neither they are perfect solid. They are called viscoelastic substance. They can be viscoelastic liquid or they can be viscoelastic solid. For example, if I talk about a viscoelastic liquid, I may have yogurt. Solid, viscoelastic solid, I may have jelly, right? So if I talk about at this point low viscous substances, so low viscous substances will be the one, they have very less resistance to deformation. So the such kind of substances are termed as low viscous substances. In contrast, we have high viscous substance. They have or they show very high restrict to deformation. They don't deform really easily. That's why they are named as highly viscous substances. So if I talk about the basic definition of viscosity, it is simple defined as it is the force of friction between different layers of fluid in a flow. So if we really want to understand, we know there are different types of viscosity, but before that we need to understand this one thing. And to understand this one thing, I want you to consider this two plate model. For example, I have these two plates, right? And between these two plates there are different layers of fluid. So what I'm going to do, I'm going to apply a shear stress which is called tau on this surface, on this plate 1. Wherever this plate is stationary, only this plate will move a bit. So there will be a deformation cause in this one plate which is on the top, and this shear stress will lead to a shear rate. Shear stress is basically just F over A, the force applied on this top layer upon on this cross sectional area. While when I talk about shear rate is the ratio of velocity by which this plate will move divided by the distance between these plates. So its units will be, and we know its units will be Pascal. So basically if I have to define shear stress, so Newton defined viscosity as the ratio of shear stress over shear rate, or your shear stress is the product of your viscosity and your shear rate. That means your shear rate is your shear stress is viscosity times of your shear rate. But now we need to understand why this concept is important. We can divide all the type of liquids we have in two categories. One is Newtonian fluids, and number two are non-Newtonian fluids. Just remember this particular expression in your mind. So basically, the Newtonian fluids, they are those fluids which resist the change in viscosity when shear rate is applied on them. For example, if I'm applying a shear stress, those fluids which will resist the change in viscosity will be termed as Newtonian fluids. For example, if I draw a graph between viscosity and shear stress, so the Newtonian fluids, this is shear rate, so the Newtonian fluid will be constant. They won't be showing any kind of change with the increase in shear rate, but the substances who will show a change in their viscosity by the change in shear stress or strain, sorry. So these kind of substances will be called as non-Newtonian fluids. This is water, which is a Newtonian fluid, and these two substances will be termed as non-Newtonian fluids. And the examples of non-Newtonian fluids can be starch, you may have yogurt, and other such kind of substances. So if I talk about the different kind of forces or the fluid behavior, your fluid behavior is dictated by three different things. Your fluid behavior is being designated by the intermolecular forces or cohesive forces between the molecule. Intermolecular forces. Number two, your shear stress or shear rate, or I can call it external force, or it is affected by your ambient pressure and temperature. So these are the three different things that really affect your fluid behavior. Now at this very point I am able to define different types of viscosity. Number one, dynamic viscosity, which can be found by rearranging the Newtonian viscosity definition. So dynamic viscosity is equal to your shear stress over shear rate. So Newton defined this, so this is also called the modified Newtonian form. And if I want to talk about your kinematic viscosity, this is the type of viscosity which is affected by your gravitational force, and this kinematic viscosity is merely dynamic viscosity or divided by density. And your dynamic viscosity is shear stress over shear rate, while your kinematic viscosity is your dynamic viscosity divided by density, and it is also affected by your gravitational acceleration and inertial and viscous forces. Also there is this one type which is called apparent viscosity. Apparent viscosity is only related to non-Newtonian fluids whose viscosity changes with applied shear rate. Sorry. So apparent viscosity, for example, for an applied shear rate for a particular fluid X, there is going to be a particular apparent viscosity for, let's say, value 1. For value 1 of shear rate, there will be an apparent viscosity of fluid X that can be called as Nx or eta A. For B amount of shear rate, it will have a different value of apparent viscosity. It may be termed as eta b. So for every value of shear rate, there is going to be a separate value of viscosity that can be termed as apparent viscosity. So these are the different concepts related to different types of viscosity. So now we have already made a concept what is rheology and how can we interlink all these three types of viscosity. In the next video, I'll be telling you about how can you find the viscosity of dry gases by using different correlation. So that's it for today. Adios.